This is Britt Caswell with another example video. In today's video, I'm covering example 1 from section 5-2 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to use the properties of exponents in order to simplify an expression. To start out with, we have problem A here, which has 81 to some fractional exponents here. Okay. Now remember, if you have two values being multiplied together that have the same base, all that you need to do is combine them into a single power or a single base and add the exponents like this. So this is the property that I'm following. It's called the product property, for those of you guys who are wondering. So in this case, both of my bases are 81. And so I can combine this into a single 81 raised to the power 5/6 plus negative 1/3. So now the properties of exponents still allow us to treat these like normal fractions. So I need to add together 5/6 and negative 1/3. So what I'm doing now is I'm finding a least common denominator. Here in this fraction, that would be 6. I'm also just going to call this subtraction because when you add a negative, really you're just subtracting. Now 1/3 is the same thing as 2/6. Now I have here 81 to the 5/6 minus 2/6, so I could subtract my numerators and get 3/6. And then I can reduce that fraction and call it 81 to the 1/2. Now recall, whenever you have something raised to the 1/2, what it's really asking you to do is to find the square root. So I'm looking for the square root of 81, which in this case is 9. So now this next one has quite a few properties to it that we're doing. You could follow these properties in a lot of different orders. Okay, I'm going to try to do it in as few steps as possible because I'm kind of lazy. Okay. So first, I'm going to try to combine my x's. I really only like having one of each kind of base if possible. So I have an x to the first in the numerator and an x to the 1/2 in the denominator. So what I'm using is something called the quotient property. The quotient property says that if you have two expressions with the same base that are being divided, you can combine them into a single expression where that exponent is being subtracted. So I am going to take x and do 1 minus 1/2, which would leave me with 1/2. And now I don't have that big hideous fraction chilling there. Now the next thing that I'm going to do is I'm going to use the distributive property. This is also called the power of a power property. The power of a power property says if you have something raised to a power that's raised to an additional power, so notice there's one base and two exponents, then you can multiply together those exponents. Okay, so this power of a power property works across multiplication. Okay, if this was added or subtracted, that's a different ballgame. But what I could do with the multiplication, or if this had been division, is I can distribute this 2/3 across my exponents. Okay, so x to the 1/2 times 2/3. All right, that's going to turn into x, the 2's cancel out, to the 1/3. And here, when I go to multiply, I have y to the 3 times 2/3. And the 3's are going to cancel out, leaving me with y squared. Now, sometimes they might want your answer written in radical form. It really just kind of depends on, what Savvas is looking for. If I was writing this as radical form, right, to the 1/3 is a cube root, so it would look like that. And the y squared, because it's not under the radical, we usually would squish it here at the front so that you don't mistake it for being cube rooted. But both of these are valid answers. Okay, it's just this one's in exponential form and this one's in radical form. Alrighty, so now let's try this next one. So this next one has a couple of features to it. First, we have a 32 here instead of variables, and a 3. I could distribute the 1/2 right away, which is what I'm going to go ahead and do. I could figure out what the 5th root of 32 is to try to get that number to be smaller. Okay, there's multiple options or multiple pathways. In this case, I'm just going to distribute that 1/2. So this turns into 3 to the 1/2 power divided by 32, and 1/2 of 2 is 1. So the 2 in the bottom here and the 2 in the top will cancel out, and that leaves me with 32 to the 1/5. So now if I think about this, 3 is a prime number. Okay, so because 3 is a prime number, I can't break it up further. So it can stay as 3 to the 1/2, or when I convert it to radical form, it'll be the square root of 3. Okay. Now 32 requires a different kind of consideration. So what I'm doing is I'm doing the prime factorization of 32. Or you might have heard it in 6th grade as a factor tree, right? So I know 32 is 4 times 8. And if I break these apart, 4 is 2 times 2. And 8 is 2 times 2 times 2. So 32 is really 2 to the 5th power. So I'm just going to rewrite this expression like that. So I have 3 to the 1/2 over 32, which is 2 to the 5th to the 1/5. Now if I use that really nice power of a power property here, I can multiply together these two exponents. So my numerator is still 3 to the 1/2, but here in the denominator, 5 times 1/5 is just 1, so 2 to the 1st power. All right, now this is exponential form, at least the solution I get for exponential form. But again, they might also want you to write it in radical form. Now if I write it in radical form, 3 to the 1/2 is the square root of 3 over 2. I find that Savvas is a little bit unclear as to which one they prefer. Alrighty, so here's our last one for example 1. So the first thing that we want to do is we want to deal with our parentheses, right? PEMDAS says parentheses and exponents first. So the 2a to the 1/3 is just going to chill over here. And I'm going to distribute the 2/3 across this multiplication, okay, using the power of a power rule. So this is a to the 1st, so 1 times 2/3 turns this into a to the 2/3. And then I have a b, and there's a 2 in the numerator and a 2 in the denominator that cancel out. So it turns into b to the 1/3. And then it's not really collecting like terms, but I'm going to bring my a's together. I just want one a. I don't want to have a bunch of separate bases. So I'm going to be going ahead and using the product property, which says if you have 2 bases and 2 exponents, and they're being multiplied together, you can add your exponents. So here, a to the 1/3 times a to the 2/3. 1/3 and 2/3 makes 3/3. And 3/3 just is 1. So this is 2 to the a. And then I have b to the 1/3. Okay, so this is if I wrote it in exponential form. If I needed to write it in radical form, that 1/3 is the cube root of b. So it would look like this. Just checking my work to make sure I didn't lie to you, and that looks good. So there we have it. There's our property of exponents. Until next time.